So today we are going to discuss about. See, in the last video we discussed about indicators. Indicators are classified into. I think we discussed about acid, bases, and salts. What do you mean by acid and bases? Then after similarly we discussed about what do you mean by indicators. Again, in indicators there are two type of indicators. Are there? One is a natural indicator. What we discussed, I think we discussed about one is we discussed about indicators. The indicators are two types are there. One is natural indicators. We discussed natural indicator. Another is synthesized indicator. Okay, or you can say artificial. Again, we discussed in this. What do you mean by turmeric? After we discuss about litmus. After we discussed about I think China rose indicator. China rose indicator. Again, we discussed here is phenolphthalein indicator. Second one will be an methyl orange. Methyl orange indicator. Okay, so this start. Apart from this, we discussed one more thing called as olfactory indicators. Okay, so which works on the smell. Okay, or we can say chemistry we are calling as odor. This is what we discussed in the last class. Okay, now we are going to discuss about second next part of the chapter here. We will discuss about this one. Okay, so we discuss about this all things. I think discuss about black stuck. We discussed about like extract, onion, blue oil, which are called as olfactory indicator. Now we are going to discuss about how the acids and bases will react with the metals. You see the given activity. This activity need the teacher assistant to 5 ml of soluble acids and test tube should take and zinc granules. Observe the surface of the zinc granules. Should see the surface of zinc they are saying. Pass the gas being evolved through a soap solution. Why are the bubbles are formed at the soap solution when burning to the burning candle and filled within bubbles? What do you observe? Repeat the activity. This line is important. See in the activity, see last 2 points are very important. See they are asking to repeat the activity with these things. One they taken as HCl and another is HNO3 and one more is also acetic acid. All the observations in all the cases are same or different. This is important. So let us see it. Uh, in the now see this is activity. You can see in this activity there is an see taken here test tube. In test tube there is an what's up sulfuric acid they taken. Okay, with sulfuric acids let me write here reactions. I will write reaction here. So they took here dilute sulfuric acid and they are asking to add zinc granules. So what happens are here we know very well already. Zinc is more reactive than hydrogen than ZnSO4 plus hydrogen gas is going to produce. Hydrogen gas will evolve. As you can see here, see from this is surface of zinc, right? And from here, hydrogen bubbles are going to produce. You see, so this hydrogen bubbles are produced at the surface of zinc, and this is allowed to pass through this direction. Through this pipe will be there, and it will come here. And here, why they use soap solution actually? Soap solution will help to trap soap solution will traps hydrogen gas. Why sir? Why should trap sir? Because hydrogen gas H2 is insoluble. Insoluble in where sir? In H2O. It want to escape, right? So that can be trapped by the soap solution, and this hydrogen gas will be, this is hydrogen gas. So this hydrogen gas have a fuel character, so it will burns in the oxygen, it forms H2O. So this hydrogen gas will be used, very well, it will be used in fuel in in jet aeroplanes, okay. Like aeroplanes, their rockets we can say. This you remember. So in this activity, they are taking sulfuric acid and they are adding water, zinc granules, and slowly the surface this reaction will take place. From the surface of the zinc, hydrogen bubbles are going to form. Okay, this gases will pass through this glass tube, and it is made to pass us through the what's the soap solution. Since this hydrogen gas is insoluble in the water, this soap solution will trap these bubbles, and when we are bringing the glowing candle near the this hydrogen gas will burn with a pop sound. So burning of hydrogen gas, burning of, so you can say this will be here you see here. So here hydrogen gas will be there. This is soap solution. The soap solution will trap these bubbles. These bubbles when it is bringing the near candle, it is going to burn. Of hydrogen gas will the pop sound. This is confirms the produced gas is hydrogen gas. So soap solution filled with an water hydrogen gas. As I said, soap solution will trap this hydrogen gas. Okay. So here at the surface, what happens are evolution of gas will take place, and this gas is passing through this glass tube. It is passing in this direction. Let's remember. Purpose of soap solution you should know, and what is a kind of test for the hydrogen gas, and where we can able to see the bubbles. Okay. Now this come to the activity. Now see the activity they given here. See, repeat this activity with some more acids like HCl, HNO3, and CH3, COOH. Okay. So are the observations in are same in all the cases are different. So this you should know. This you should know that. See. So here very important thing is here. You try to understand. They taken here dilute sulfuric acid. So let me write plus Zn gives rise to ZnSO4 plus hydrogen gas. Okay, this is whatever the activity they given here. They're asking you people to repeat this activity instead of zinc, instead of H2SO4, you should take dilute HCl. What happens, sir? You see here, when you are taking this one, HCl plus Zn gives rise to ZnCl2 plus H2 gas. This is the reaction. Now see here, let's just see here, 2 moles, when we should balance here, 2 chlorines are there. Now see here, how many moles of hydrogen is, how many, how many moles of HCl is required to produce 1 mole of hydrogen here? How many moles are here? 2 moles is required here. Now in this case, you see how many moles here only? 1 mole is sufficient to produce what? 1 hydrogen gas. This is one point where you should understand. Now, and one more thing is this is also an what we can say, this is also strong acid. Okay, so this is also what's that? This is also strong acid. No need to worry whether the same extent the production of hydrogen will take place or not. Okay. Now they are asking to repeat the activity with one more HNO3. So HNO3 they are taking here Zn. What about here, sir? So what is your expectation actually? Expectation will be there. Expectation. What is expectation here, sir? Okay. You see here again. I'm writing here. So HNO3, okay, HNO3 diluted, they are saying diluted HNO3 plus Zn. What happens earlier? So actually we will expect that ZnNO3 zinc nitrate will form plus H2 it has to produce, correct, right? But here, what happens here? This is one more, it has character of oxidizing agent. So this nitric acid have a property of oxidizing agent. That's what they even repeat the activity with this, very well. Here we are going to trap you. Okay. So back like oxidizing, it means what's that? First this reaction will take place and immediately this HNO3 will add what's a oxygen. Will add the oxygen here. Okay, this addition of oxygen will take place with this one, and instead of H2O, H2 plus O2 gives rise to what's a H2O will form. Okay, so what is the final equations are here right here? It has to form this above product, but NO3 taken twice plus NO2 gas plus H2O will take place. What is the reason, sir? Here, because you remember, HNO3 will be act like what's our oxidizing agent. It will add the oxygen for the produced hydrogen gas. Okay, so one more thing, one more question why the given sir here. One more example they given sir. What is example, sir? You can see here. Example they given here. So I repeat the activity. One more substance. What is the one more substance? They taken CS3, COOH. Okay, plus Zn. So what happens are here? Here what happens are CS3, COO. Okay, taken twice. Zn will form. Okay, so plus hydrogen gas will produced. Okay, this is compound name what sir? This is an zinc acetate. Zinc. What about this amount of hydrogen gas you see here? We record here 2 moles. Here also we record here 2 moles. 2 moles is required. So we can say 2 mole of acetic acid. Acetic acid will produce how many moles are? 1 mole of H2. One more thing is here. Amount of gas, amount of gas produced, produced in case of CS3, COH as compare, as compared to what sir? Compared to H2SO4 is less. Why sir is why it is less sir? Because CH3 COOH is weak acid. Means what sir? Produces less H plus ions. Okay, that's why they given this one. Okay, which one they given sir? That's why to trap you people they given here three things. What about sir? In case of HCl, in case of in case of HCl, what's sir? Same amount. Same because it's an what's sir? Strong acid. Strong acid, but you should remember 2 HCl, 2 mole of HCl will produce what's sir? 1 mole of H2. Okay. In case of HNO3, what happens sir? Okay, no hydrogen gas. Because what sir? Because HNO3, what is the nature of HNO3 sir? It will act like a oxidizing, oxidizing agent. Okay. So in case of CS3, COH, what happens sir here? Here also, amount of H2 gas is less because what's that? Because CH3 COOH is weak acid. Okay, just remember. These are the important things where you should understand with that activity. Okay, just please remember. Now see. Now come to the next one. What they given here. So now metal plus acid useless. What is the condition? By this equation, finally should know that there is a conclusion here. So when there is a reaction between metal plus acid, gives rise to what, sir? It gives salt and hydrogen gas. Okay, how we can confirm hydrogen gas, sir? Produces hydrogen gas, burns with also with pop sound. So pop sound test we can do for confirmation for hydrogen gas. Okay. So finally this is important here. Metal plus acid gives rise to salt and hydrogen gas. Okay. Now metal plus base. So metal plus base they give an example here. Generally all metals this is remember all metals is not reacts with okay bases okay because there is no such condition to react okay so few are there example like zinc and aluminum so take an example zinc plus NaOH zinc plus NaOH used as to sodium zincate what is the formula of sodium zincate Na2ZnO2 okay plus hydrogen gas also hydrogen gas will be there yeah? So it is called also it's called a sodium zincate sodium zincate okay similarly if I take an aluminum plus NaOH so we'll get here uh, aluminum zincate I think so AlZnO2 use plus source are again hydrogen gas which is aluminum zincate okay clear so generally this basis will react with only two they given here because not there is no such condition that all the metal need to be reactive. This is of more reactive. Few active metal like zinc and aluminum can react. Okay. So next one you see. Next what the given here. Next the given activity. Place the two. Next the given. Can you rewrite equation for this one? Take this. This to take this reaction also should warm the mixture. That is also condition they given here. Next you see here how this metal carbonate, metal hydrogen carbonate react with the how this metal carbonate and metal bicarbonate hydrogen carbonate react with the acid. So here we can say better take this picture. Okay. Just you can take here. And see here this what happens here actually. Let me write here better. Okay. See the diagram here. Now see here. So this reactions actually they given here. Two things are there. First one is metal metal carbonates metal carbonates plus acid. What happens to metal carbonate plus acid? You see, metal carbonate plus acid. See, you try to understand here. Example, I take Na2CO3 plus they take dilute acid HCl. Okay, so here three things are important. Whenever you are seeing left side CO3, in chemistry generally right side there will be a CO2, carbon dioxide plus water plus you get salt. So here you have salt. Na is from metal and Cl from the acid, so we get NaCl. Okay, now this production of which gas? There is a production of carbon dioxide gas. You should remember this is very important here. This gas is going to produce. Okay, so how this gas is conformed? So now you can see here they taken sodium carbonate here, and the sodium carbonate is reacting, making react with the dilute hydrochloric acid. Slowly, this gas is produced here. CO2 gas will produced here. CO2 gas will pass to this glass pipe and glass tube. It's going to make to pass us through the lime water. This calcium hydroxide is called lime water. So here calcium CaOH taken twice will be there. Lime water will be there here. So you can say this is lime water. Okay, and plus CO2 will be there here. CO2. So aqueous you can say lime water aqueous solutions, and it forms CaCO3, calcium hydrogen carbonate, which is a solid and which is an milky white, which is an milky, you can say milky white. So this milky white confirm formation of CaCO3 plus H2 is going to form. This is one more thing you should understand that this reaction is when we are passing limited limited CO2. So there are two reactions are there. One is limited. If we are passing excessive, if we are passing the excessive amount, what happens again? Suppose here same reaction, so you can see if we are passing, so same CaOS taken twice will be there and plus CO2 will be there. It forms what's a CaCO3 solid. Okay, plus what's a H2O. Again, this one if you're supplying for this one if supplying excess amount, suppose excess when you're passing excess, you can write I'll write here CO2. Okay, so this gives rise to what's that? This gives rise to CaHCO3, calcium hydrogen carbonate. Calcium hydrogen carbonate, and this will be what's that? This is colorless. Is colorless. Okay, this is available in the aqueous state only. Calcium hydrogen carbonate will be formed. Okay, so the excess amount of water, limited supply, it is going to form. This is not excess. You can write here limited CO2. This is the result. Excess CO2, excess CO2. This is the result. Okay, please remember. Okay, after so if you taken the metal bicarbonate also same will be there. Okay, metal bicarbonate. So you can see that metal bicarbonate you can see here they given sodium hydrogen carbonate right reaction. Okay, sodium hydrogen carbonate. Here also you can see NaOH, NaHCO3. Metal sodium hydrogen carbonate plus again dilute HCl gives rise to again same NaCl salt, form the salt producing water H2O and produces water CO2 gas. So how they can confirm, how they can give the question about the CO2? It can, you know very well, it is going to extinguish the fire. Okay, this is extinguishes the fire, so it is called, which is extinguishes the fire, they can ask, or else we can say this will be a brisk effervescence. Brisk effervescence, which is related towards the CO2 gas. Okay, it will be put off the fire, which can put off the fire, put off what we can say glowing candle. So gas which turns lime water to milky. These are all things. It's like water to milky, brisk effervescence, fire extinguisher, which can put out the glowing candle. These are all talking about what's a CO2 gas. Remember, okay. Now after come to the next concept, they given about slime moderators. You please remember here two things are there. One is limited supply, excess. You can see they given here excess. They given here excess carbon dioxide following reaction take place. Calcium hydrogen carbonate is going to form. Okay, so limestone you can see very important here. They given here limestone. What is the formula of limestone? This is CaCO3. What is the formula of sharpie? CaCO3. What is the formula of marble? CaCO3. Or the different forms of calcium carbonate. All the metal carbonates and hydrogen carbonates react with an acid to give the corresponding salt, carbon dioxide, and water. Like write general equation. So metal carbonate, or we can say metal hydrogen carbonate gives rise to what, sir? We use salt plus water plus CO2. Okay, so let me write here better. What is the general equation, sir? So general equation for metal metal carbonate, or we can say, or metal hydrogen carbonate. Metal hydrogen carbonate is also called what, sir? Metal bicarbonate plus dilute acid. What they give, sir? They give three things. One is salt. Second one is what, sir? H2O. Third one is what, sir? CO2 gas. This is very, very important. CO2 gas is important. Okay. So remember, and after next concept. See, next concept, what they given, sir? How do all the bases and all the acids and bases react with each other? They given the activity here. Take 2 ml of Na, 2 ml of NaOH solution in test tube, and add the few drops of phenolphthalein solutions and color of solutions. Okay, so dilute HCl solutions and above solution drop by drop, and it is there any color changes for the reactions mixture? Why did this color of phenolphthalein changes after the addition of acids? And now add 12 drops of NaOH to the above mixture. Does pink color of phenolphthalein reappear? Why do you think this happens? So they're asking here. I can understand. So first thing what they're saying, sir. First thing they're saying that so first they are saying to take a solution, few drops of they taken the test tube. Okay, we test tube, try to understand here. So test tube. In test tube they are taking what's that? Few drops of, sorry, few what we can say, ml of, so think like 5 ml of NaOH solution. Aqueous solution means aqueous solution. What they are taking, sir, they are adding a few drops of water, drops of phenolphthalein phenolphthalein indicator. Okay, what is the colors are now after addition this one, this is pink color because this is base. So in basic medium pink will be the phenolphthalein. Okay, now see, and add what they're asking, sir. Next they're asking you people to add dilute HCl. So what happens are here we have a NaOH, we have NaOH solution, and this one what we added, sir, we added now drop wise dilute HCl. What happens, sir? It is then neutralized. Acid will produce what, sir? H plus ion. Base will produce what, sir? OH minus ion. These two will combine. These two will combine, or they will form, sir, will form a water. Now try to understand here. Now with NaOH is a basic in nature. This is a base, right? This is base. This is what, sir? This is acid. So what is the reason for its basic nature? Because it is OH. But OH is removed from the base now. Similarly, what are the responsible part of this HCl which can show the acidic characters are H plus. That is only produced now. Both will come and will form H2O. Remaining words are remaining will be NaCl. So this is what, sir? This is water. Okay, this is what, sir? This is a salt. So acid plus metal, acid plus you can write here. So acid plus base. Acid plus base gives rise to what, sir? Is giving salt and water. This reaction is, if you are going to touch this surface of this test tube, it will be some water. Warm means it is going to produce what, sir? Heat energy. That's why it is also called what, sir? So name of this reaction is neutralization reaction. Neutralization reaction. And this also called what, sir? This also called exothermal. Do you know what is the reason for exothermal, sir? Because this reaction heat is produced. Now see, they're asking. See, we took the test tube and we added this so and so so and so. Again, after addition of See, first NaOH we take. What is the color of phenolphthalein colors in that time? Color will be what, sir? Pink color. Again, what we added, sir? We added what, sir? HCl. Converted into what, sir? NaCl plus H2O. Is it this Na which is present here? The answer is no. That's why what we can say, pink color, what's that? Disappears. Disappears when we added the HCl. Okay. Now for this one, now we have mixture. What mixture we have? NaCl plus H2O. This is mixture right now. Whatever we have. Suppose for this one, if we're adding NaOH, adding NaOH. Now see this one NaOH will be more. Again this again what happens? Again turns into pink color because of what, sir? We added NaOH. Basic nature is increases. Basic nature color will be what, sir? Pink color. Try to understand here. Okay. Now what I'm saying here. So now try to understand here. Just write here better. There is an test tube. Okay. Test tube was there. Okay. We added here what, sir? We added NaOH. Okay, and plus what's up? Plus phenolphthalein. Okay, plus phenolphthalein. What is the color, sir? Color will be somewhat pink color, sir. Is the color, sir? Pink color. This color, sir? Pink light is a pink color. The pink color it is. What color, sir? It is a pink color. Okay. Now what is the color, sir? It is a pink color. Now for this one we added what, sir? This one we added pink color returns into what, sir? Now this pink color returns into what, sir? So now we added what, sir? NaOH plus what, sir? HCl we added. So here what we have? We have phenolphthalein. What is the color, sir, now? Now it is which color, sir? It is a colorless. It is a colorless. What is the reason, sir, here? Acid is more. Now again this one. Again what we have, sir? Here we added. Then what happens, sir, again? Becomes what, sir? Becomes pink color. Again what, sir? Again we added what, sir? Again we have at the beginning we have NaOH, then we added what, sir? HCl, and cancel neutralization. Now again what we are adding again? NaOH. So what we can say, sir, here? Here NaOH is more. What, sir, here? HCl is more. What is more, sir, here? NaOH is more. Okay. Now see NaOH. Here what we have, sir? Here we have NaOH plus HCl. Here what we have, sir? Here we have NaCl plus H2O plus what, sir? NaOH. NaOH is, that's why color is what, sir? Is pink color. Okay, let's remember. Now see. Now come to the next concept. For the next concept, sir, we have uh, metallic oxide with acids. Reaction of non-metallic oxide with the bases. Okay, now to discuss about this one. Now see, we go with the next process. Okay, next reaction. So generally, they given here metal oxides, metal oxides with less acids. What happens over so metal oxides? See, metal oxides we use salt and water. Salt and water. Then what is the nature of this metal oxide? You know very well. With the acid, something else giving salt and water. And what may be the nature of metal oxide. Yes, we discussed that with acid which gives salt and water, sir. We discussed about NaOH plus what, sir, plus HCl gives rise to what, sir? Gives rise to NaCl plus H2O. This reaction what we call, sir? We call as a neutralization. Neutralization reaction. What is the nature of this? Whenever it's place, what we have metal oxide. In nature of metal oxides, they are the basic in nature. Example, we can say, I'll take magnesium oxide plus I'll take dilute HCl gives rise to magnesium GCl2 plus H2O. What is the nature of this one, sir? Magnesium oxides are basic in nature. Okay, let's understand. Next we have, so is it all the metal oxides are basic in nature? Again we have Al2O3. Again we have lead oxide. Again we have zinc oxide. After the manganese oxide, we have beryllium oxide. These oxides are what we can say. We have SnO2. These all are amphoteric oxides. Remember, amphoteric means they act like both acid as well as base. Okay, so example, if I take an Al2O3, when made and react with HCl, they forms what's that? AlCl3, AlCl3 plus H2O. So in this process, it acts like what's that? Base. Similarly, if I take the same Al2O3 plus NaOH, used as to what's that? Used as to aluminum, sodium aluminate, NaAlO2 plus H2O. Okay, this is also salt and water. Like what's our acid. Okay, now come to the non-metal oxides. See, non-metal oxides are acidic in nature. So you know very well this. This we discussed about Ca, which lime water, right? This lime water is nature of lime water, sir. Lime water is what's basic in nature. Plus we are passing what's CO2 gas. What happens, sir? It forms CaCO3. CaCO3 plus H2O. This is also salt. Salt and water. What is the nature of this one, sir? This is acid. Why? Because salt and water is produced. Salt and water is there, and this is an basic acid. So with base, which will be substance for the salt and water, sir? This is acid. So non-metal oxides are acidic in. Anyway, we have carbon monoxide. Okay, we have N2O. These are the what we can say, sir, neutral. These are the neutral, neither acidic and nor basic. Okay, let's understand. About SO2, sir, SO2 will react with H2, it forms H2 SO3. This is also acidic in nature. Okay, so non-metal oxides are acidic in nature. Metal oxides are basic in nature. Okay, please remember.